Next topic is time operations on signal. Time operations on signal. So there are three operations that we can perform on a signal. Three time operations. First is called as time shifting. We will understand time shifting with an example. So let us say x of t is a signal which is going from 0 to 5, and let us say that the amplitude is 2. So x of t is a signal which goes from 0 to 5 with an amplitude of 2. Then what will be x of t minus 2? So for x of t minus 2, we shift this signal in time by 2 units. So this signal will start from 2 instead of 0, and this will end at 7 instead of 5. So if you observe, this signal is shifted in time by 2 units. The amplitude remains same because we are doing operations on time. The signal shifting to the right hand side is called as time delay. The signal shifting to the right hand side is called as time delay. There is another thing which is called as time advance. So if I say x of t plus 3, in this case the signal is shifted to the left hand side by 3 units of time. Therefore, instead of starting at 0, this will start at minus 3, and instead of starting at 5, this will start at 2. The amplitude remains same, which is 2. This is called as time advance. This is called as time advance. Therefore, a signal can be shifted in time using two techniques. Either it will be delayed in time. For time delay, it is shifted to the right hand side, whereas a signal can be advanced in time. For time advance, it will be shifted to the left hand side. Second operation is time scaling. In time scaling, also there are two variations. First, again, let us start with a signal x of t, which is triangular in shape from 0 to 5, and the amplitude is 2. First, we look at x of 3t. So x of 3t, we will divide every time value by 3. So in this case, the signal will go from 0 to 5 by 3. For x of 3t, we divide every time value by 3. So 0 divided by 3 is 0, 5 divided by 3 is 5 by 3. The amplitude remains same. This operation is called as time compression. Such a scaling operation is called as time compression. There is another variation. Now we can plot x of t by 2. What will be x of t by 2? In x of t by 2, we multiply every time value by 2. Therefore, the signal will go from 0 to 10. So 0 is multiplied by 2. So 0 multiplied by 2 is 0, and 5 multiplied by 2 is 10. So in x of t by 2, we multiply every time value by 2. This is called as time expansion. This operation is called as time expansion. Therefore, in time scaling, we can perform two types of operation. One is time compression, where the signal is compressed in time. One is time expansion, where the signal is expanded in time. For time compression, we divide every time value by 3 in this case. Whereas for time expansion, we multiply by 2 for this example. Suppose you have x of 5t, then you should divide every time value by 5. Suppose you have x of t by 5, then you should multiply every time value by 5. The third and final time operation that we can perform is called as the time reversal, also referred to as folding. Time reversal, also referred to as folding. Now in time reversal, we reverse the signal in time. That is, you take the mirror image of the signal along y-axis. So x of minus t in this case will be, the signal is starting from 0 to, now instead of 0 to 5, this will go from 0 to minus 5. Amplitude will remain 2. Therefore, in time reversal, we fold the signal or reverse the signal or take symmetric image of the signal along y-axis, mirror image of the signal along y-axis. This is called as time reversal. Time reversal is also referred to as folding. Time reversal is also referred to as folding. Let us take an example where the signal x of t starts from minus 1 goes to 2, and we want to plot these different versions of x of t. All these 8 examples are based on the 3 time operations that we have looked at, namely time shifting, time scaling and time reversal. So let us plot each one of them. What will be x of t minus 2? X of t minus 2 will be shifted to the right hand side by 2 units. So if I have to plot x of t minus 2, x of t minus 2 will be if this is shifted in time by 2 units, this will be 1, 2, 3, 4. The amplitude remains same. This is 1 and this is 2. This will be x of t minus 2. Second is x of t plus 1. So this is the first one. Second, x of t plus 1. So x of t plus 1 will shift to the left hand side by 1 unit. So x of t plus 1 will be 1, 0, minus 1 and minus 2. So it will start from minus 2 to minus 1. The amplitude will be 1 and 2 respectively. These 2 examples are for time shifting. This is time delay, this is time advance. Third, is x of 2t. What will happen in case of x of 2t? For x of 2t, we divide every time value by 2. Therefore, this is 0.5, 0, 0.5 and 1. Amplitude remains same. So if you observe, for x of 2t, every time value is divided by 2. Next is x of t by 3. in x of t by 3, x of t by 3, we multiply every time value, by 3. We multiply every time value by 3 because this is x of 3t. So x of 2t is an example of time compression, whereas x of 3t is an example of time expansion. Fifth is x of minus t. Fifth is x of minus t. X of minus t is an example of time reversal. So if you want to reverse this signal, the reverse version of this signal will be 1, 0, minus 1 and minus 2. The amplitude is 1 and 2. This is the time reversed version of the given signal. Now if you observe the sixth question we have to perform two operations. First is we want t plus 2, which refers to time shifting, and we want minus t, which refers to time reversal. Therefore in sixth question we have to perform two operations. One is time shifting and the other is time reversal. Question like this can be difficult. Therefore I would recommend you to first always perform time shifting, and the second operation can be time reversal or time scaling. But the first operation should always be time shifting in such questions. I will draw the sixth one. So in the sixth question, we want x of minus t plus 2. So x of minus t plus 2, first I will draw the time shifted version of the signal x of t plus 2. So x of t plus 2, the signal will shift to the left hand side by 2 units of in time. Therefore, this will start from minus 3, minus 2, minus 1, 0. The amplitude will be 1 and 2. But we want x of minus t plus 2. So we will now perform time reversal. So if we perform the time reversal, x of minus t plus 2 will be, you just reverse this signal along the y-axis or take mirror image of the signal along y-axis. This will be x of minus t plus 2. Similarly, you can solve the seventh question, which is x of minus t minus 3. For x of minus t minus 3, first you should perform the shifting operation, which is x of t minus 3. And then you should take the reversal of that, which will become x of minus t minus 3. For eighth question, there are two operations again. First operation is x of t plus 3, which refers to time shifting. Then we want 3t plus 3. So 3t refers to the time scaling. In case of 8th also, the first operation that we will perform is time shifting, which will be x of t plus 3. And then we will perform the scaling, which is x of 3t plus 3. We now look at the seventh one, which is x of minus t minus 3. Very similar to sixth. In seventh also, very similar to sixth. In seventh also, the first operation that we will perform will be time shifting. So we will start with x of t minus 3. In x of t minus 3, the signal will shift to the right hand side by 3 units of time. So This will start from 2, 3, 4 and this will end at 5. But we want x of minus t minus 3. So now this has to be reversed along the y-axis. So x of minus t minus 3 will become so again we have to perform two operations. First is shifting, second is reversal. Sorry, this was number 7th. In 8th question again we will first perform the time shifting. So in 8th question we will first perform x of t plus 3. We will first perform x of t plus 3. In x of t plus 3, the signal will shift to the left hand side by 3 units in time. Therefore, the signal will start. The signal will start from minus 1 and will extend up to minus 4. But we want x of 3t plus 3. X of 3t means we have to perform time scaling. So every time value has to be divided by 3. So x of 3t plus 3 will be this is x of 3t plus 3 where we have divided every time value by 3. So minus 4 becomes minus 4 by 3, minus 3 divided by minus 3 becomes minus 1, minus 2 by 3 and minus 1 by 3. This is an example of continuous time signal where we have performed 3 time operations: time shifting, time scaling, time reversal. We will also take an example of discrete time. This is a discrete time signal. For this signal, we have to plot number 1 x of n plus 1, number 2 x of n minus 2, number 3 x of 2n, number 4 x of n by 3, number 5 x of minus n, 6th x of minus n minus 1, 7th x of minus n minus 2 plus 2, 8th x of 3n plus 1. I would like everyone to plot this. Let us plot the first example, which is x of n plus 1. In x of n plus 1, the signal will shift to the left hand side by 1 unit in time. This will be x of n plus 1 where the signal has shifted to the left by 1 unit in time. X of n plus 1 is an example of time advance. Second example is x of n minus 2. In x of n minus 2, the signal will shift to the right hand side by 2 units in time. The signal has shifted to the right hand side by 2 units in time. This is an example of time delay. In x of 2n, every time value is divided by 2, and it is an example of time compression. Fourth is x of n by 3. In n by 3, in x of n by 3, every time value is multiplied by 3, and it is an example of time expansion. In x of minus n, the signal is reversed in time along the y-axis. That is, you can take the mirror image of the signal along y-axis. So in time reversal, instead of the signal going from minus 1 to 4, it goes from 1 to minus 4. In sixth example, we are doing x of minus n minus 1. So again, as you observe, there are two operations. N minus 1 refers to time shifting and minus n refers to time reversal. As I already told you, when there are multiple operations to be performed, we first perform time shifting and then we perform the other operation. So here also we will first perform the time shifting. So in the sixth question, we will first perform time shifting, which is n minus 1. X of n minus 1. So n minus 1 will start from 0. X of minus n minus 1. So now we perform the time reversal. So in time reversal, this will again start from 0, but instead of going to the right hand side, this is now going towards the left hand side. This will be x of minus n minus 1. We can similarly plot x of minus n plus 2 and x of 3n plus 1. So first we will perform the time shifting, which is x of n plus 2. and now we reverse the signal. So x of minus n plus 2 this will be x of minus n plus 2. So first we perform the shifting, then we perform the reversal. In 8th question, there are two operations. First is time shifting, that is n plus 1, and second operation is time scaling, where you have to do x of 3n. So first we will perform time shifting and then we will perform the time scaling. So first we perform the time shifting, which is n plus 1, n plus 3, sorry, you want n plus 1. So in 8th question, first we perform the time shifting, which is n plus 1. So first we perform x of n plus 1, then we want x of 3n. In x of 3n, in x of 3n plus 1, we divide every time value by 3. This will be x of 3n plus 1. Before I wrap up this exercise, I would like to tell you some important points. Now first of all, this is a discrete time signal, and as we already know, in discrete time signal, time cannot take any value. Time can take only integer values. Now if you observe 2 by 3, 2 by 3 is not an integer. 1 by 3 is not an integer. Again, 1 by 3 is not an integer. 2 by 3 is not an integer. Therefore, if I report the answer like this, it would be wrong. Since this is a discrete time signal and only integer values are allowed, I have to discard, we have to remove the non-integer values. Therefore, the final answer to this question will be x of 3n plus 1 will be, I have to take only two samples which are at integer values of time, discarding those at non-integer values. Therefore, at 0 we will have 1 and at 1 we will have 1 by 2. This should be the final answer for 8th. If you report the answer like this, you will be given full marks. If you report the answer like this, it would be incorrect. So always remember, when you are in discrete time signal, always discard, always remove non-integer values. Only take those which are integer values. Now, I will again revisit the question number 3 that we have solved in this example. Now, in number 3, we have calculated x of 2n. So I am again revisiting the question number 3 where we had calculated x of 2n. So this is x of 2n. Now again, if you observe x of 2n, there are non-integer values of time. Which are the non-integer values of time? So minus 1 by 2 is a non-integer value and it has to be discarded or removed. 1 by 2 is again a non-integer value. This has to be removed. 3 by 2 is a non-integer value. It has to be removed. So if I report the answer to question number 3 like this, it would be incorrect. So the correct answer to question number 3 will be x of 2n. At 0, this will be 1. At 1, this will be 1. And at 2, this will be half. That would be the correct answer. This answer is obtained by retaining only the integer values and discarding the non-integer values. But remember, this integer non-integer differentiation you will do only for discrete time signal. Do not do this if you are shifting scaling the continuous time signal. With this, we wrap up the time operation on signals. We will take a couple of questions on time operations of signal. In the first question, two signals f of t and g of t are given to us. We have to find the relation between f of t and g of t. How do we find the relation between f of t and g of t? First of all, I will shift f of t by 1.5 units in time. This will be shifted to the right hand side by 1.5 units. So 0 will go to 1.5 and 1 will go to 2.5. The amplitude remains 1. Then we will do the scaling operation. So we will do f of t by 2 minus 1.5. So since we are doing f of t by 2, every time value should get multiplied by 2. So 1.5 becomes 3 because since this is f of t by 2, time should get multiplied by 2. So 1.5 multiplied by 2 is 3 and 2.5 multiplied by 2 is 5. Amplitude is 1. Now if you observe, this signal and this signal are same. Therefore, we can say that g of t is nothing but f of t by 2 minus 1.5. Therefore, g of t is f of t by 2 minus 3 by 2. This is the relation between f of t and g of t. This is the second question we are taking on time operations. In the second question, the signal x of n is given to you. We have to plot y of n. Y of n is given by x of n by 2 minus 1. Again, we would plot y of n in two steps. First, we will perform the time shifting x of n minus 1 and then we will scale it by n by 2. So, what will be x of n minus 1? So, x of n minus 1 will be shifting to the right hand side by 1 unit in time. So, this is x of n minus 1. Then x of n by 2. X of n by 2 means every time value should be multiplied by 2. So this is minus 2, 0, 2, 4, 6. This is 1 by 2, 1, 2, 1 and 1 by 2. So, and this is nothing but y of n. Now, if you observe, the signal y of n exists only for even values of time. That is, signal y of n, x of n by 2 minus 1 exists only for even values of time. So, this is the final answer.